Question number 3. A student tests two substances, solid R and solid S. Test on solid R. Table 3.1 shows the test and the student's observations for solid R. So here's table 3.1. Test 1. The student gently heat about half of solid R in a boiling tube. In the observation, we have white solid forms a colorless liquid. When steam comes out from the boiling tube and condensation forms at the top of the boiling tube. In test 2, the remaining solid R is dissolved in distilled water, form solution R. Solution R is divided into 4 portions. To the first portion of solution R, add aqueous sodium hydroxide dropwise and then in excess. White precipitate forms. The white precipitate dissolves in excess aqueous sodium hydroxide. Now this must be the test for positive ion. And as they are saying white precipitate, it's soluble in excess of sodium hydroxide. If you look at the list for cations or positive ions, here's the list. And with aqueous sodium hydroxide, we have Al3 plus and Zn2 plus. These are the ions that form white precipitate and they are soluble in excess, giving a colorless solution. So for your convenience, I'm writing down the name of these ions here. We have Al plus 3 or Zn plus 2. Test 3. To the second portion of R, solution R, add aqueous ammonia dropwise and then in excess. White precipitate forms. The white precipitate remains in excess aqueous ammonia. This is also the test for the cations. You see the effect of aqueous ammonia on both Al3 plus and Zn2 plus, and you will see that only Al3 plus gives white precipitate which remains or which is insoluble in excess. It's not, or it can't be Zn2 plus because the white precipitate formed by Zn2 plus, it will be soluble in excess, giving a color solution. So there's Al plus 3 or 3 plus ion. Moving to next test. Just test 4. To the third portion of solution R, add 1 centimeter cube of dilute nitric acid, followed by a few drops of aqueous barium nitrate. No change. This is a test for the anion, and barium nitrate is used to test the presence of sulfate ion. You see, it's a test for sulfate ion. Barium nitrate is used after adding dilute nitric acid, and it should give white precipitate if sulfate ion is there. And as there is no change in this case, so SO4 minus 2 absent. Test 5. To the fourth portion of solution R, add 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate. Cream precipitate forms, and this is the test for the fluoride, bromide, and iodide ion. You see, in all these, we used to acidify with dilute nitric acid and then add aqueous silver nitrate. So only the bromide ion gives cream precipitate. So it must be having Br negative ion in it. Now let's see the questions. Question number part A. State the conclusion that can be made from observations in test 1. If you look at the test 1, there's white solid forming a colorless liquid, and there's steam also coming out of the boiling tube and condensation forms at the top of the boiling tube. It means that solid R must be having water chemically combined with the salt. And the term we use for this is known as water of crystallization. So you can write contains water of crystallization. E. Identify solid R. Now, looking at these tests and observation, what we have concluded it must be having Al plus 3 and Br minus. So you are going to write down here Al3 plus or aluminium and also Br minus or bromide. This will be the identity of solid R. Now test on solid S. Solid S is sodium sulfide. Now they gave us the name of the compound, which is sodium sulfide here. Record the expected observations. See, the student carries out a flame test on solid S. Observations. Sodium sulfide is containing Na plus ion and sulfide is SO3 minus 2 or SO3 2 minus. So the flame test, it must be for Na plus ion. So let's see the color for the Na plus ion for flame test. Here's a flame test. It gives yellow. So you'll write yellow. This will be the observation for the flame test carried out with this solid S. The student dissolves the remaining solid S in distilled water to form solution S. The student divides solution S into two portions. Now, student has divided this into two portions. To the first portion of solution S, the student adds about 2 centimeter cube of aqueous sodium hydroxide. Observations. So this is a test for the use for the presence of the cations, and we don't have the test for the Na plus ion with sodium hydroxide, as sodium hydroxide also contains Na plus ion. So there will be no change. If you look at the list, for the convenience, I'm showing the list. There's a test for the cations here. We don't have Na plus ion in the list. And you can't carry out the test for Na plus ion with sodium hydroxide also. We used to test Al3 plus, NH4 positive, Ca2 plus, Cr3 plus, Cu2 plus, Fe2 plus, Fe3 plus, or Zn2 plus. So you write no change here. E. To the second portion of solution S, the student adds a few drops of acidified aqueous potassium magnate 7. Observations. This must be the test for the presence of the anion sulfide here. This is sulfide. You see, if you add small volume of acidified aqueous potassium magnate 7, this will change its color from purple to colorless. So you will write purple is decolorized or purple to colorless. Purple is decolorized or purple to colorless. Both these statements are correct in this case. Moving to last question, which is question number 4. A mixture contains 3 solid compounds: aluminium oxide, calcium carbonate, calcium chloride. Table 4.1 gives some information about the 3 compounds in the mixture. Here's table 4.1. Aluminum oxide, it's insoluble in water, but it reacts with sodium hydroxide to form a soluble compound. What about calcium carbonate? Calcium carbonate, it's insoluble in water. It has no effect on adding aqueous sodium hydroxide. Calcium chloride is soluble in water and it reacts with sodium hydroxide to form an insoluble compound. Plan an experiment to find the percentage by mass of calcium carbonate in the mixture. Your plan must include how you will calculate the percentage by mass of calcium carbonate in the mixture. You are provided with a sample of the mixture, distilled water, aqueous sodium hydroxide, and common laboratory apparatus. The total mark for this question is 6. So we need to find the percentage by mass of calcium carbonate. So it means we have to exclude both aluminum oxide and calcium chloride from this mixture. We have to remove these two. Remove these two. So first of all, the first step, it must be you have to weight or find the mass of solid mixture. Weigh or find the mass of solid mixture. It's very important because then you will be able to find the percentage by mass of calcium carbonate in the end. The next step, what I'm going to do, I will add distilled water. As you can see, calcium chloride is soluble in water. Both aluminum oxide and calcium carbonate are insoluble. So in this way, we will be able to remove calcium chloride. So I will add distilled water. Add distilled water to the mixture, solid mixture. And in order to mix calcium chloride completely, we have to use a glass rod or stirrer and stir with glass rod. You can even write stirrer or stirrer. Next step, we have to filter using filter funnel. In this way, we can remove calcium chloride from this mixture. Filter. You will do the filter using filter funnel. Then now start these steps with residue. If you want, you can add an additional step, that is wash the residue with distilled water so that whatever calcium chloride left in the residue, it will be removed. So you will write wash with distilled water. The residue. This one is optional. Okay. Next step, what we are going to do, then we'll add. Now, whatever we are going to do, we will do this with the residue, because in the residue, we have aluminum oxide and calcium chloride. Fine, I'm going to write, we have aluminum oxide plus calcium carbonate. This will be in the residue. So I will add excess sodium hydroxide so that it will react with aluminum oxide. To residue. And we need to stir again in order to mix the content. Now again, I need to filter. In this way, I'll be left with the residue, which is now containing calcium carbonate on the filter paper. Filter. And wash the residue. Why I'm going to write the wash the residue? This time you have to wash the residue, because whatever soluble substance present on the residue, it will be removed. Wash the residue with distilled water. Or for residue, you can even write or, as you know, calcium carbonate will be left as the residue, calcium carbonate with distilled water. Try the residue. Residue is calcium carbonate, remember. Now, we will weigh this calcium carbonate, weigh the calcium carbonate. Or you can write even residue or residue because it's in the residue. Calculate the percentage, calculate the percentage of calcium carbonate. How you're going to calculate? You have the mass of calcium carbonate multiply by 100 and divided by the initial mass of solid mixture. Now this is of 6 marks and you can choose any 7 points from these. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. You can write any 7 from these. Any 7. In this way, you can gain 6 marks. Definitely, you're going to gain 6 marks. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.